Today we are going to start looking at composite transformations. So what exactly is a composite transformation? Well, we have the word composite and transformation. Now we already know transformation, right, means a change in size or location. So if we can figure out what composite means, or if we know what the word composite means, then we just kind of piece them together and make our own definition. Okay, composite, just keeping it simple, means multiple. Okay, so a composite transformation is basically multiple transformations. Now our flow map to do composite transformations isn't really a flow map. You just need to go in order of transformation given. And on page 10, we'll actually see a couple of these examples. So first thing I want to do is try to translate by this rule, and then you'll have a transition word that tells you like what your next step is after you do the first transformation. So this particular example, I'm translating, then reflecting. And just like with previous examples, just do it point by point. So -5, -1. This is A by the rule XY. So -5, -1 becomes -5 plus 6 and -1 minus 3, which is equal to 1, -4. All right, another way of thinking it is right 6, down 3. Now after I do this, then I reflect over the y-axis. So there's my y-axis. Now I just use the rule of reflections. So if I'm 1 to the right, I need to go 1 to the left. And this will be a double prime. Now the double primes and the single primes is just after how many transformations. So after one transformation, I was at the point 1, -4. After 2, I was at -1, -4. Okay, so I would go through here and I would do this for all of the points, right? Again, I'm still only focusing on one point, because if we can do it for one point, we can do it for an entire figure. Again, this time I have reflection. Then so that's my transition word, and I'm going to have reflection again. I'm just going to use the point 1, 1 since it's the closest to the origin. I'm less likely to misplot it. Okay, so reflect over the x-axis. So reflect over the x-axis. I'm 1 above. That tells me I need to go 1 below. And that's 1, -1. Then reflect over the y-axis on my new line of reflection. It's the y-axis. And I'm 1 to the right, so I go 1 to the left. -1, -1. Okay. And I'm done. Right? I would choose the figure that's got -1, -1. If multiple figures have -1, -1 for A double prime is my answer, then I'm gonna choose a different letter. Okay. I want to do D on page. Nope, I lied. We'll just go to page 12. And we'll just do A. No rhyme or reason. I wanted to see if I had one that I could dilate, but I don't have one of those kinds of questions. Again, closest to the origin. It'll probably be L. -3, -2. Translate it by the rules. So I'm going right 3, up 2. So right 3, up 2 gets me to the origin. And then reflect over the y-axis. So I'm going to reflect over here. And remember, if you're on the point or the line of reflection, you don't leave it. So essentially you don't move, right? Because I'm neither 0, up, down, left, or right away from it. So to get to it, I don't move. So therefore, my movement after it's reflected is going to stay the same. Just because this one was weird, we'll do another one. So -3, 2. Go to the right 3, and then up 2. Again, this is T prime, so I'm at 4. Whoops, excuse me. 0, 4. Again, reflect across this line. Because I'm on a line, it doesn't move. -5, -1. Right 3, up 2 is A prime. Now here, to the line, I'm 2 to the left, so I need to go 2 to the right. And that gives me the point 2, 1. All right, so composite transformations, if you took your time, you understood reflections, rotations, translations, dilations, it's not going to be any harder. You're just essentially doing 2 problems in one. Again, in each of these examples I went in the order that I was given. Extremely important. If you don't go in the order that you're given them, you will get it wrong 99% of the time.